Hello, everyone. It's beginning.
No, not yet. Let's wait another 10 seconds.
Oh, okay, thanks.
Yeah, only 10 participants into now. I'm expecting to see more. Okay, so hello everyone, welcome to Karmada bi-weekly English meeting. My name is Ying. I'm a software engineer at Zendesk. Our company is adapting Karmada to managing Kubernetes clusters. I'm excited to be your host for today's meeting. And just a reminder before we get started, this meeting is being recorded and will be available on YouTube Karmada community channel later. The topics are listed here in the agenda. If you have any topics outside of the agenda, just have them for the end. If you have any questions during the discussion, feel free to ask or share your comments and questions in the chat. Uh, all right, let's get started. The first on the agenda is from Jun Chang. He's gonna walk us through the proposal for multi-cluster service. I'm gonna over to you, Chang.
Uh,
Are you gonna share
okay,
screen or?
okay, thanks. Let me introduce the proposal for introduce the multi-class service API to ex. Uh, can we share the screen?
Sure.
Uh, okay, thanks. Okay, can you see my screen?
Yes, I can see your
Yes.
screen.
Okay. Today, hello everyone. Today I will propose about multi-class service API. It expose and it discover multi-class service. We have implemented the MCS filter based on the MCS API proposed by SIG multi-class to solve the problem of service discovery between multi-classes. However, MCS function don't solve the problem of multi-class service exposed. This proposal proposes a new multi-class service API for exploring multi-class service on OSI layer 4. The multi-class service forwards the external traffic to the backend of the member class service managed by Karmada, breaking through the boundary restriction of a single service and implementing unified ingress of traffic from multi-classes. Uh, what's the motivation? Uh, the multi-class service allow users to easily manage service and application in multiple Kubernetes clusters. Help users quickly and simply implement load balancing and therefore network traffic routing among multi-Kubernetes class. In addition, user needs to create multiple resource when using the existing MCS filter, which is not user friendly. It's hoped that the creation of the multi-class service resource can unify user behavior. What's the goals? First, define the multi-class service API to support the expose of multi-class service. The second, integrate the multi-class service discovery atomic capability implemented by based on the MCS API and provide use with more abstract and simple resource definition through the multi-class service API. And the third propose the shared interface of for different cloud providers to implement the provider's specific functionality. Uh, and the no goals is the implementation of the interconnection with the load balance service by the specific cloud provider. Let us say the user story. Uh, User story one as an end user to ensure high available and improve class fault tolerance. User needs to deploy the same service in different clusters in multiple regions and expose the service to the load balance service on the cloud provider. In this way, during access, requests can be eventually distributed to the backend instance in different clusters. The story two, as an user, when using the MCS filter based on the MCS API to discover service between the clusters, they need to create multiple resources. For example, service export, service import, propagation policy, which is complex. If unified API is provided, the usage threshold is lowered. Um, let's say the uh, design details. Uh, we propose multi-class service API. It's like this. The multi-class service is named objection of multi-class software service. The name field of the multi-class service is the same as that of the service name. Service with the same name in different classes are regarded as the same service and are associated with the same multi-class service. Uh, we can use it to control the expose of the service and enable service discovery between the classes. It has time meta, and object meta. Besides, it has spec and status. The status is uh, the service, the status of the service. Um, what class spec is like? It has types. It's a slice. It specifies how to expose the service reference by this multi-class service. The expose type uh, uh, has has two expose type. The first one is cross cluster. We can use it to enable the service, the discovery service. The second is the load balance service. We can use it to expose the service. Uh, Besides, we have the ports in spec. It is a list of the ports that are exposed by this multi-class service. If we do not specific the port, it will be it will expose the all ports the reference service have. Uh, the no specific port will be filtered out during the service expose and the discovery process. Um, the what's the expose port like? It has the name field and the port field. It specifies the port name in the reference service. And we have a range field. It specifies the range where the reference service should be supposed. It only valid for the types contains cross cluster type. If we not set it uh, uh, and the types contains cross class type, all class will be selected. That's the multi-class service API. Anyone has have some question? Let me continue. We design the shared interface for multi-class service. It can user can implement those interface to uh, expose the service to the specific cloud provider. The following is the example for user how to use the expose function. First, user can create the deployment set and deployments and service, and propagate them to the member cluster, and then create the multi-class service resource. Third, the controller in the Karmada control plane will register the port IP address with the LB instance using the multi-class provider gun the specific one. And the last user can access the LB the load balance then then to the backend the service backend on the different service. The YAML is like this. Another type is cross cluster. The YAML is like this. We like this. The user deployment multi-class service and then controller in the commander will generate the service export and the service import and then propagate them to the member cluster. Then the existing MCS function will start work. As the last, the service request can access from the member 2 to member 1. Just like this. Below the following is some more detailed design for the multi-class service. What's the behavior when updating the multi-class service? It will determine the change of the types value and process them based on the latest value, while cleaning up the any reduced types if they exist. And what's the behavior when deleting the multi-class service? It will clean up the previous impacts service, impact the resource. And what's the behavior when the refreshing service doesn't exist? The multi-class service resource will fail to be created. And what's the behavior when some imported class don't exist? The Karmada will generate an warning event and ignore the no exist cluster. And what's the behavior when some important class disappear? Command will clean up the impact caused by this cluster. Let's see the restriction statement. The first one is a single cluster can expel. Sorry, this one is pass has been passed. Uh, I will update it. Uh, the only restriction will be the LBA instance should be able to direct access the pod network in the command member cluster. Um, Before is implementation steps. We split it into two repo, the Karmada repo and the multi-class cloud provider repo. And here are some validation and test plan. That's all. Thanks. Uh, Anyone has hello.
Thank you, Jen. Before we move on to the next topic, do we have any questions from our audience? I have a quick one. So when are we gonna when can we expecting to see this feature being implemented? I know it's currently a proposal, but our companies and us would like to give this feature a try in the coming quarter.
Sorry.
Okay, yeah. I have a question. Please go back to the second example. Second example, yeah, I think it's in the that's one. In the example, I can see the cluster will be exposed to member one, right?
Yeah.
I think
I made a mistake.
Yeah.
It should be member two. If this is one is member one, this one is member two. The example here should be member two. So sorry, I made a mistake.
Okay. Yeah. Okay. Thanks.
Hello. I have
Hi.
some questions. Yeah. Uh, okay. First one. Why we not choose other multi-class service solution like service mesh? So why we need a multi-class service? This first one. And if we not create service in member cluster, how can we do service governance? Okay, it's one question. Okay.
The first one is service.
I can help to answer the question. I think multi-class service is a light way to achieve the service management. Yeah, I think Istio can do such thing too, but we are trying the light way, I think.
Okay. So we don't need a Istio or like other service mesh there is just only the multi-class service we can do or the service governance.
Yes. For the use story addressed by the proposal, we think we can just use multi-cluster service but the multi-class service has some limitations or some features. Yeah, I think ETH might be more powerful, but multi-class service might be simple and easy to use.
Okay, it's cool. So I have another question. If we create a multi-class service, just export service with cloud LB, how about local cluster, Kubernetes cluster? And if we
How about what?
How about local provide Kubernetes cluster provide? If we not use a cloud provider like Huawei, Alibaba, or yeah.
I get your question. Yeah, I think you are asking if a Kubernetes cluster deployed cloud provider and the service type might be load balancer type, right? So how to export the load balancer IP to the this LB, right?
Okay.
Yeah, as I think that's a good question. We need to consider it a little bit.
Okay. Maybe we need more detail in the proposal document. Okay.
Yes. Okay. Sure.
The last one question. Okay. If we host all service in Karmada control plane, if Karmada control plane was down, we multi-cluster service will down also.
I don't think so. Even if Karmada control plane broken or down, if Karmada has registered the service IP to some load balancer, I think the load balancer will continue to work. But at the meantime, Karmada will not keep updating the load balancer, I think.
Okay. I found the description at the cross-cluster service discover. If Karmada control plane was done or broken, now service how we do service export or service import. If we can do this, maybe the service and the pod change. We cannot get the latest pod IP or service information.
I think if Karmada after Karmada down, I think Karmada will cannot sync the service between clusters anymore.
Yeah.
Yes, I think I don't know. I don't know what we can do if Karmada down.
Maybe as one question after meeting we can think more. Okay.
Yeah, I think you can leave comments on the PR.
Yeah.
We can talk about it. Okay, thanks.
Okay. Oh, thanks you guys.
Thanks.
All right, let's move on to the next topic. It's from I believe it's Tiecheng, another proposal about re-imitation, policy re-imitation. Sorry, preemption, policy preemption.
Hello, everyone. Can I share the screen?
Yes, go ahead.
Okay. Can you guys see the proposal?
Yes, we can.
Okay. This proposal is about the policy supports preemption by priority at runtime. Currently, our propagation policy and the cluster propagation policy already have a notion of priority. If multiple policies match the workload, Karmada will select the one with the highest priority. However, the priority only takes effect during the first matching of the resource template. Once a resource template is selected by a policy, it cannot be preempted by a subsequent policy, even it has a higher priority. You can see the example in the following. It is a policy with priority 2, and at the first match we will select the policy with the highest priority. But this proposal proposes a strategy which allows policies to support preemption by a priority at runtime, which means even if workloads have been propagated by a policy, they can be preempted by a high priority of a policy. Here is the motivation of this proposal. Cast administrator usually cannot foresee future expansion scenarios when configuration policies. They will usually start with a broad policy to set the base strategy, such as a common cluster propaganda policy to match all of the resources. When an application requires special configurations, the administrator want to provide a personalized policy to take over the application. At this time, it hopes that the high priority policy can preempt the low priority policy. So our goal is to extension the API of propagation policy and cluster propagation policy to allow high priority policies to preempt low priority policies, and propose the implementation ideas for involved components, including Karmada Control Manager and Karmada Webhook. And we propose a solution which is compatible with previous versions. This preemption capabilities will be disabled by default. Upgrading the system from the previous version to the new one will not result in any change in behavior and will not require any additional adoption work. So here is a user story. As a cluster administrator, I hope that the higher priority policy can preempt the low priority policy. So this is I introduced in the following. So I let's skip it and talk about the risk and migrations. This proposal maintains backward compatibility, the system built with the previous versions of Karmada can be seamlessly migrated to the new version. And our talk about with priority, such as our priority now has two kind of priority. One is explicit, and the other one is implicit. So the priority based on preemption do not include implicit priority when the spec and priority of policies are the same. So for example, the following two policies will not preempt, such as the first one, we use label selector to match the kind of some specific deployment, and the other one use name to match a specific deployment with Nginx. So these two kind of policy will do not preempt. So let's see the design details. For the API change, this proposal proposed a new field preemption for determining whether to allow this policy to preempt other policy. We have added the priority to the propagation spec, and now we will add a new field to preemption. This is a bool type, and it indicates whether the policy is allowed to preempt low priority policies. If true, it will preempt those workloads whose previously matched policy has a lower priority than it. Okay, it defaults to false, so it will not influence business which you have deployed. For example, assume that policy it is an example policy Nginx propagation has bound workload Nginx, and you can see the resource binding, the label of resource binding. We can see the propaganda policy's name and namespace. It means the template Nginx has matched the policy Nginx propagation. So now assume that there is a high priority policy which allows preemption. For example, we have a priority 3, and we allow this policy to preempt those whose priority is less than it. So in that case, this policy will preempt the above policy, and the deployment will be scheduled to member 3 because of it is the later the Nginx propagation preemption is fully adopted. So will be scheduled to member 3. So here is some components change. First is Karmada controller manager. Currently, when new policy creates or updates, a detector will first check whether existing objects are no longer matched by the current policy to handle the changes of resource selectors. If yes, we will clean the labels on the unmatched object. Then it will find the corresponding resource binding and make sure that the policies update can be synced to the resource binding. Finally, it will try to find the matched resource templates which have not scheduled. So to allow preemption, we will add some preemption logic to the process. Sorry, my picture is broken. I will try to Okay, let's see this picture. It will show the process of the full process. For example, when a policy event coming, for example, create or update, we will check if it allows preemption. If no, it's so keep the old logic and the same. If yes, we will first find a matched resource template and from a map. This map is maintained by the common by the inner structure of Karmada controller. So it indicates a result template and the binding relationship between the result template and the policy. So we will compare the priority with the matched one and the coming one. So if the new policy is the priority is larger than the old one, so we will clean up the labels in template, which means okay, this result template is need to be rescheduled and need to try to find a new policy again. So in the looking for matching policy again, it will be a calculation to match the highest priority policy. So it will be the same logic of formal. So as about the map logic, it is it will be very simple logic. It may be a key as a result template. The formal key such as namespace name, and the value is the priority of it uh, it now current have. So it when we need to check the coming policies priority and the priority which it has adopt. So we need this data structure. Okay, let's come back to the proposal. So among this, we need to record the mapping relationship between policy and result templates, and for each preemption operation, the component need to have a corresponding matrix record, because the preemption option is very dangerous, because it may influence workloads across clusters. So it's better to show some metrics and events to users about how Karmada to preempt to do this preemptive operation. For example, we might record the preemption counts, and for each preemption option, we will send an event to the users, and the finally one is the test plan. So we will fully test this new feature and keep the no break change will be involved by this feature. Okay, this is more on my part. If you have any questions, can you can ask.
Any questions, concerns, suggestions for this proposal? I'm gonna take this silence as a no. Yes. Again, if you have any comments, feel free to put in this proposal PR. And thank you, James.
Thank you.
Looks like we covered both topics on the agenda today. Before we end the meeting, Hongfei, do you have any updates?
No, thanks.
Yeah. Okay, cool. Any questions from audience? Okay. All right, and thank you so much for your time and your participation today. The next meeting will be in 2 weeks from now, going to be in July the 11th. And I guess that will be all for today. Thank you again, and see you next time.
Okay, bye.
Thank you.
Bye. Thank you.